Working with veneer can be a real creative challenge, opening up a whole new dimension of woodworking. Sometimes, though, veneer is viewed as too fussy, too technical. Why would anyone want to work with this fragile, thin piece of veneer when you could work with this nice, solid piece of hardwood? Hello, my name is Darrell Keel, and I think there are some very good reasons to use this material. In this video, I'll show you why working with veneer is a skill well worth learning, and how to work with it to achieve a high-quality finished product. Now, although veneer has often been associated with cheap, shoddy construction, a superficial covering, the fact is, since Egyptians first used veneer over 3,000 years ago, many of the finest pieces of furniture ever built were adorned with veneer. Go to any museum, you will find an amazing selection of beautifully veneered pieces. Is there something these furniture makers saw in veneer that has been overlooked? What are the reasons they chose to use this seemingly fragile, unruly material? One reason is the incredible selection. The available species and types of cut is almost endless. Look at the choices. This is Macassar ebony, curly koa, Chilean laurel burl, lacewood, quilted mahogany, curly redwood, walnut burl, mahogany crotch. Just look at the flame pattern. The list goes on. Here's a regular piece of maple. Here's another piece of maple, curly maple. Here's some bird's eye maple. Maple burl. Maple butt, taken from the stump of the tree. Quilted maple. A lot of choices for one wood. Start sequence matching, adding inlays, patterns in different directions, like this radial match. Mahogany crotch, and you've got a whole world of possibilities. The second reason, and maybe the primary one, can be understood by considering this concept. Using veneer allows you to separate how a particular project is built structurally from how it appears visually. By separating these two aspects, the structure of a piece and the surface treatment, the woodworker is given a whole new level of design freedom. Gone are the traditional constraints associated with solid wood. The restrictions one must consider when working with solid wood are eliminated with veneer. Let's examine these two items to explain what I mean. Here is a common raised panel door. Now, I bet a lot of people think this frame and panel door was built this way because it looks nice. And I think it does, but the real reason is about the basic characteristics of solid wood. First, it moves. It expands, contracts, warps, twists, everything but stands still. This single fact is the #1 consideration before building any object out of solid wood, if you want it to last, that is. The other consideration is solid wood is inherently stronger with the grain and weaker across the grain. Let's take a closer look at these points. This panel floats in the groove so it can move with the seasonal humidity changes. These 4 frame pieces are arranged this way not because it's more attractive, but because it minimizes the overall movement of the entire door and maximizes the strength with the grain. If the grain in this top and bottom rail ran up and down like the side pieces, this door would move way too much over the course of a year to fit well on its cabinet and probably break apart after a few good slams. Here is another panel that completely ignores these rules. This curved drawer front is veneered. If we look closely, you will notice the grain of the frame pieces runs the short way. Exactly what I just said wouldn't work on the other door. Also, the center panel does not float in the frame, totally disregarding expansion and contraction. Because this panel is made of plywood, basically layers of a thicker veneer laid up perpendicular to each other, the face layer of decorative veneer can be applied without the traditional constraints associated with solid wood. This opens up a tremendous freedom, allowing woodworkers a whole new level of design options. What I like to do is combine these two materials, veneer and solid wood, which gives me something that neither one can achieve on its own. Here's a piece I built for a customer that demonstrates what I mean. Look at the top. This is just not something I could ever have considered in solid wood. Same with the apron. Now add these solid details, like this edging and the shapes on the legs, and a whole new level of design can be achieved. See the possibilities? Now that we've examined the concepts behind veneering and seen some examples, let's look at the different forms veneer comes in and how to purchase them. First, veneers sliced from the log generally come in three forms. Rotary cut, which is peeled from the log as the log turns. Quarter cut, which is sliced perpendicular to the annual rings. This means from the outside of the log to the center. And third, plain sliced, which is cut across the log. Let me show you what each cut looks like in this cherry. Rotary cut looks like this, not particularly attractive. Look at this wavy, random grain pattern. Rotary cut is used for faces of construction-grade plywood, or the B side of furniture-grade plywood. One of the few exceptions is this bird's eye maple, which is rotary cut to maximize the eyes that you see in this piece. Quarter cut looks like this, very linear and graphic. Some woods, like this Macassar ebony, are usually cut like this to accentuate this linear look, and often because particular species do not look appealing, cut another way. Plain sliced, which is the most common cut, looks like this, with the cathedral grain pattern. This cut looks most like solid boards. Let's put all three side by side, rotary, quartered, and plain sliced. See the differences. Be aware that the look of each cut will allow you to make better design decisions when planning a piece. Remember, not all species come in different cuts. Some are sliced only one way. There are a few other cuts, but these are the ones you will find most readily available. Now you can purchase your veneer in this raw state, or you can get it backed, usually with a 5 or 10 mil paper. The advantage of the paper backed is the individual slices of veneer have been seamed together, eliminating cutting, trimming, and taping, steps we'll cover later. The main disadvantage is a much smaller species selection and types of cuts, and you don't get to put the individual pieces together the way you like. I prefer working with raw veneer, even though it's more work. It would be difficult to get this look with paper-backed veneer. If you decide that paper-backed will suit your project, it usually comes in 3 common sizes: 2x2, 2x4, and 2x8. If you decide to purchase raw veneer, there are a few things to keep in mind. Always buy veneer in sequence. Each piece is in order as it was cut off the tree. Here is a beautiful curly koa I purchased some time ago. Each piece is in correct order. When I go to book match this veneer, each piece will be a perfect reflection of the adjoining piece. There are usually 24 pieces per bundle called a book, but you don't have to always buy an entire book. Be aware that raw veneer comes random width and length. You can rarely specify the actual size. When purchasing veneer, you can ask to get, let's say, 6 inches wide by 7 feet long, and the supplier will find something close that will yield those dimensions. Raw veneer will either come clipped, meaning the rough edges have been trimmed, or it will come as it was cut off the log, often narrower at one end than the other. Here's a piece of maple with raw edges. It's rarely this bad, but it demonstrates what I mean. Remember, veneer that comes clipped appears straight, but it will still need to be trimmed by you to achieve a tight joint. In terms of veneer thickness, you rarely have a choice in this matter. Veneer comes anywhere from a 28th to a 42nd, most of it around a 32nd, with the more expensive and exotics closer to a 42nd. A few of the common species can be purchased at a full 16th, like this walnut, usually used for bent laminations rather than face veneering. Success in getting you what you want will largely depend on the company you get it from. Shop around. If you're placing a decent size order, some veneer companies are particularly service-oriented and will even send you an individual piece so you can preview it before buying the amount you need. You may want to pick up one of these sample boxes from a veneer company who has a selection of different veneers. This can help you familiarize yourself with the different species. When I've decided what I want and how much, I always buy extra. For example, let's say I'm making a cabinet with 4 sequence-matched doors, and each door will have 4 pieces of veneer. Rather than buying just 16 pieces, I'll get 24. If you get just enough and something goes wrong, by the time you call to get more of that same veneer, there's a good chance the bundle yours came out of will be gone. Try explaining that when your customer asks you why that door doesn't look like all the rest. Be aware that the larger veneer suppliers sell by the flitch only, which is half the entire log or the entire log. This can be thousands of feet and thousands of dollars. I look for a supplier who usually works with a custom shop. Once you've purchased your veneer and it arrives, there are 2 things I always do right away. If you're getting full-length pieces, they will probably come like this. Let's take a look. Not only is this an easy way to ship long lengths, but it also protects them from damage. The first thing I do is unroll and lay the veneer flat. Veneer left rolled for any length of time will begin to assume the rolled shape, making it difficult to work with. Small bundles, like this burl, usually come flat. No need to unroll. The second thing I do, which I consider very important, is number each piece. If you've gone through all the trouble to make sure your veneer is sequenced, number each piece on the end to make sure it stays that way. 1, 2, 3, 4, and so on. For storage, I recommend making a simple wall rack like this one to keep it stored out of the way. Veneer that's moved around often or has other items placed on top of it will quickly become cracked, split, and useless. Now that a veneer is numbered, let's decide what to make with it. I have chosen this walnut burl. It's such a classic veneer. It will also give me a chance to demonstrate all the techniques required to work a more difficult veneer. This burl in a 4-way match would make a beautiful tabletop. So I'm going to make this into a top for a coffee table. The first thing I'm going to do is make sure these pieces are numbered. Let's see. Yes, they are. Like I said before, this step is very important, especially when creating a multi-piece match like this 4-way burl. I'll talk more about matching in a few minutes. Now this particular burl is reasonably flat, but not all burls come this way. Here's another one that I could not work in its present condition. When working with buckled veneers such as this burl, it's often necessary to pre-flatten before cutting and taping. Although veneers like this can intimidate the beginner, by following a simple flattening procedure, this burl can be made as workable as any other. I use this simple formula that not only flattens the veneer, but also sizes it, which keeps it flat even if you don't use it for a while. Here's how it works. Take 4 parts water, 2 parts white or yellow glue, 1 part denatured alcohol, and 1 part glycerin, available at any drugstore, mixed together thoroughly. The glycerin helps make the veneer pliable, alcohol aids penetration, and the glue sizes the veneer, keeping it flat until it's used. I'm going to brush this solution liberally on both sides of the veneer and let it soak in. This will allow the veneer to become pliable before applying pressure. Now that the veneer is soft, I need to flatten it and remove the moisture. I do this by placing a standard piece of fiberglass screen on each side of the veneer. And then place 3 or 4 layers of newspaper on top of the screen. The newspaper serves as a blotter to draw out the moisture, and the screen prevents the newspaper from becoming glued to the veneer. I'm going to place a cover sheet on top of the sandwich and place the entire stack in the press. I'm using a vacuum press to flatten the veneers, but any type of press will do. A couple of boards with clamps work fine. After a couple hours under pressure, I need to remove the stack and change the paper. Let's take a look. As you can see, the veneer is flat, but definitely not dry. The newspaper is saturated with moisture and needs to be changed. I will continue to change the paper until the veneer is completely dry. About 6 times, usually 3 times the first day and 3 times the second day. I only use the screen on the first 2 times, since the newspaper won't usually stick after that. On the second day, I continue changing the paper, but no longer in the press. Just keep a heavy object, like a gallon of glue, on top of the stack. I know this sounds like a lot of work, but don't rush it. Veneer that is not completely dry will shrink and crack if glued down too soon, and will probably not adhere properly. Often the veneer feels dry at the end of the first day, but don't be tempted to work it then. Be sure to continue the second day. 2 nice benefits of this flattening method are if you don't use the veneer right away, it will stay flat for months as long as you keep a cover sheet on top of it, applying a little pressure. Also, on open-grained wood, like this walnut, this formula will greatly reduce or eliminate glue bleed-through when pressed. Of course, if you can avoid it, get flat veneer. That's great. Sometimes suppliers will have their buckled veneers pre-flattened, like the one I'll be using on the tabletop. I always ask before taking a buckled one. Here are a few more pieces I flattened a few days ago of this buckled veneer. Looks pretty good compared to the unflattened one. Before I actually do any cutting, I always like to preview the options first. On a burl like this, there are so many different ways to create a four-way match that I can't afford to try all the choices and then decide. So I preview the possibilities with these mirrors. Let me show you how it's done. Let's say I think this corner would look nice as the four-way match. I'll hold these mirrors like this and there, an instant four-way match. Now let's say I wonder how it would look with this as the center. I move the mirrors and there's another instant match. Once I've found the look I want, I just lightly mark the veneer like this. And I'm ready to cut. This technique can also be used to preview radial matches like this, and can even be used for simple book matching like this. I find this tool indispensable in the veneering process. Now that I've marked my veneer and I know what it will look like, it's time to cut the individual pieces. Let's take a look at the different cutting tools. This is probably the most common cutting tool, the veneer saw. It has a flat face that goes against a straight edge with a row of fine teeth on its curved edge and cuts like this. Another choice is a veneer knife, which is used the same way as the veneer saw. Now, I know a lot of people think, why should I buy a special veneer knife when I can use an inexpensive mat knife? I don't recommend it. The blade in this knife wanders too much, and your finished seams will not come together well. This veneer knife also allows me to get a firm grip the way the blade is held in place, and eliminates any chance of wandering during the cut. These two tools allow you to cut only one piece of veneer at a time, and cutting with the veneer knife should always be done on the underside of the veneer because it creates a slight V as it cuts. When I tape these two pieces together, this side being the side I cut on, the seam on this side will be very tight, whereas on the underside will be slightly open. Of these two, I prefer the veneer knife myself. I like the cutting action rather than the sawing action, and I'm also left-handed and have not seen one for left-handed people. If you want to cut a number of sheets at once, there are a few simple jigs you can make. The simplest is just to clamp the veneer between two boards and run it over the joiner. I find this technique a bit awkward and somewhat dangerous, since I usually need to remove the guard off the joiner, and I'm not crazy about the clamps hanging out over the blade. Also, it eats up the boards in the process. The two I like are used with the router or the table saw. Let's take a look at the table saw jig first. This one consists of two pieces of plywood connected at both ends and a strip on the underside that runs in the miter slot of the table saw. The veneer slips in between the plywood and then is run over the table saw with a strip in the miter slot. Use a blade with as many teeth as possible for the finest cut. Although this method is fast and easy, it's prone to chipping the veneer, and I usually reserve this technique for veneer going on the back side of a panel or veneer that doesn't easily chip. My preferred jig is this one that works with a router. Its big advantage over the table saw is it pinches the veneer, eliminating any chipping and tear out. The veneer slides here and then is clamped on both ends. The beams are purposely bowed to apply pressure in the center when clamped at the ends. Sometimes I'll add an additional clamp in the middle if the veneer is especially buckled. I use a plunge router, although any router will do, with a carbide flush trimmer. The bearing rides on this lower piece as I trim the veneer. I usually run the router backwards, called climb cutting. This technique can stop even the worst veneer from chipping out. Sometimes I even lightly sand the edge to remove any fuzz that might have been left with the router. This is the jig that I will use to trim the walnut burl veneer. The first thing I'm going to do is tape these 5 pieces together. Note I'm using 5 instead of 4 in this match. I always add an extra piece just for the just in case. Better than going back later to trim another piece. Now, when I go to tape these pieces together, I line them up accurately if I want the grain patterns to match. I look for a prominent feature like this burl here and then carefully line them up. There. I know when I trim this bundle, all the pieces will be cut in the same place. The next thing I want to do is make sure these pencil marks are on the top piece. Okay, let's tape the bundle together. Now I'm ready to trim, so I'll slide this bundle in the jig. Now on a delicate veneer like this, I usually trim twice, once to remove most of the veneer, and in a second pass take off an additional 1/16 down to the final line. Okay, let's clamp this. Now I'm going to slide it out a 1/16. Clamp it once again. Notice this time that I'm routing backwards, called climb cutting. Let's take a look, see how it came out. Looks good. No chip out. Which means I flip it over. Seam looks tight. And the match is symmetrical. Now I'm going to tape these two halves together separately. And then make the perpendicular cut along this edge. I find this is easier than trying to make a perfect right angle cut on all four pieces, which if slightly off will only be compounded when I try to bring them all together. When creating a veneered panel with more than one piece of veneer, these individual pieces must be tied together in some way to keep the joints tight when pressing. The most common way is with veneer tape. It usually comes in two forms, 2-hole and no hole. Either one works fine. Today I'm going to use 2-hole. A note about masking tape. Don't use it. You'll only try it once. These tapes stick much too hard and can be next to impossible to get off. Even a low stick painter's type I don't recommend because they are too thick and leave indentations in the veneer after pressing, creating additional sanding. Veneer tape has a glue-coated back that requires wetting before applying. You can use a fancy tape dispenser like this that wets the veneer tape as you pull it over this roller. Or you can go low-tech with a simple standard kitchen sponge. I like the tape dispenser, but a low-budget alternative is this ceramic roller that I found at an office supply store. You fill it up with water, and then the wheel rotates as you pull the veneer tape across it. Not as high-tech, but better than a sponge. I won't use this masking tape to tape the seams, but I do find it handy to temporarily hold the pieces in place while I put on the veneer tape on the other side. I'll put a piece on both ends and a few pieces down the middle, which should be sufficient for this length of veneer. Before we go any further, I need to talk about matching and sequencing. There are basically two ways to match veneer. Slip, which is laying the veneer side by side, like this, which gives you what I call the board look, similar to glued up solid boards. The other way is book matched. Which is where every piece is flipped over, opened up like a book. This is the most common and dramatic way to match veneer, since each piece appears to be a mirror of the next, creating an interesting grain pattern. Four-way, radial, and diamond matching are all considered book matched, just arranged differently. The other consideration is sequencing, which is basically which piece will go where in what order. Remember earlier how I numbered the veneers in the corner. Now is when I need to check those numbers and arrange the veneers accordingly. Now if I'm laying up what I call a straight run book matched panel where all the pieces are side by side, I'm going to start with number 1 and go from there. 1, 2, 3, 4, 5, with every other number facing up. But when I'm doing a four-way or radial match, I approach it a little differently. With straight run matching, each piece will never come in contact with any other except the next number up or down. Number 1 will never touch number 4. With four-way matching and radial, this is not always the case. Let's take a look. With this four-way match, you can see that number 1 is touching number 4 along this seam. Now you may ask, why is this a problem? And in many cases it is not. But on some veneers, especially highly figured ones with intricate grain patterns, you may notice this pattern does not match up well along this seam. Even though the veneer is cut very thin compared to solid wood, the grain pattern does change from piece to piece. And the further you go, the greater the change. With a radial match like this 8-way, the change can be even more noticeable. Let me show you the solution I use. Instead of going around like this, I alternate the pieces like this. With this technique, a piece of veneer will never touch another more than 2 numbers higher than itself. The highest number number 1 will touch is number 3. This may not be perfect, but it's highly unlikely the difference will be noticed. Let's see how it would look on this 8-way radial match. Using this method, I'm going to tape number 1 to number 3 and number 2 to number 4. Let's line these up carefully. Put on the temporary masking tape. Flip these over, double check the seam, double check the numbers. Now I'll do the other pair. Okay, flip these over and double check the numbers. 2 and 4 and 1 and 3. Okay, looks good. Now traditionally, one would place a cross piece of veneer tape every few inches and then place one long piece down the entire seam. With the masking tape on the back, this can usually be eliminated, or maybe just a few, depending on how flat the veneer is. A little side note about how flat does veneer have to be. If the veneer is too difficult to tape together and get a good seam, then it needs to be pre-flattened. The veneer I'm using may not be perfectly flat, but it's definitely good enough. This veneer is impossible. I could never get this seam to come together. This seam looks pretty good. Let's put one long piece down the seam. Like this. And rub down firmly. Sometimes I use a wallpaper roller on a difficult spot. Let's do the same on the other match. Don't forget, remove the masking tape. I always do it immediately. Now that that's done, let's prepare for the final cut. I'm going to take this square and mark a line perpendicular to the tape joint. Line these two pieces up together. Put on a couple more pieces of masking tape to hold the two pieces together. Now we're ready to cut. And slide this in the jig. I'll make a rough pass first. And now I'll make the final cut, running the router backwards. I'll line up these two halves. Put the masking tape on the back side. Flip it over and tape the front side. A little over length there. and remove the masking tape. There, all done. Let's take a look at the match. Looks good. Tight seams and nice symmetrical grain pattern. Now that our face is all done, we have two more things to prepare. A veneer for the back side and a substrate to press the veneer onto. I always look for a veneer of similar thickness and density for the back side. This will help to prevent the panel from warping over time. I'm using a mahogany, which is a similar density to the walnut, but much less expensive. I always put a veneer on the back side to balance tension. Otherwise, the panel could warp badly. Let's take a look at the possible substrate materials. For many years, the most common core material used for veneering was plywood, being a number of thicker plies running perpendicular to each other. Today, much of the core material is either furniture-grade particle board or MDF, a denser, finer version of particle board. MDF stands for medium density fiberboard. Now, many people might say, how can I put particle board underneath this fine burl veneer, viewing this as the lowest form of substrate? But this isn't true. There are very good reasons to consider these two materials. Their big advantage is complete dimensional stability. They have no grain direction. The number one rule in laying up veneer is always run the grain perpendicular to the preceding layer. This is not an issue with particle board or MDF. Let's take this four-way match we're going to glue up. The grain pattern is going in so many different directions, it's hard to find which way is perpendicular. With particle board or MDF, this is not an issue. This surface is omnidirectional. And I also get maximum use from a sheet since I don't have to think about grain direction when I go to cut the sheet up. This is not to say I don't like veneering on plywood. I do, just that I consider the project and choose the substrate material accordingly. Don't let particle board's bad reputation scare you away. It's a first-rate substrate for veneering. Whether you choose particle board or MDF is really your choice. I've heard arguments both ways and have used both with excellent results. In general, I prefer MDF, but either one works well. Sometimes MDF can be a little hard to locate, and if you use particle board, be sure it's cabinet or furniture grade, not underlayment grade. Once I've chosen the substrate, my next decision is the edge treatment. Do I want to cover this edge now or after I press the face veneer? And is the edge going to be veneer or is it going to be solid? On this piece, since it will be a tabletop and I want to put a profile on the edge, I'm going to use this piece of solid walnut. I've also decided to put it on afterwards since this table will be in a high trafficked area and I want to protect the veneered edge from chipping. If this was a cabinet side or a door, I would be less concerned and might decide to apply the edging first. In general, I prefer to veneer the face first since this allows me to press the panel large and trim to size afterwards. Now that I've decided what substrate to use, and I'll be putting on the edging later, I'm almost ready to press the veneer. This panel is cut an inch oversize, and the veneer is trimmed to the same size as the panel. I've also cut two cover sheets, one for the top and one for the bottom. Notice they are melamine coated to prevent glue squeeze through from sticking to them. If you can't get coated cover sheets, polyethylene sheeting like this 4mm plastic taped to a cover sheet will work well. A good source for melamine coated sheets is shower stall coated masonite which is what I'm using here, commonly found at a lumber center. Let's take a few minutes and talk about the last consideration before I press this panel: which glues to use. As you can see, there are a number of glues to choose from, and understanding the right glue for the right veneer is a very important decision. The long-term success or failure of a veneered panel is often determined by the glue. Each of these glue types has different properties, and different veneers can also require different glues. Understanding these properties will allow you to make the best decision. First, let's consider what glue is supposed to accomplish. This walnut burl veneer we are using wants to expand and contract just like solid wood. The difference is this piece has been cut thin enough that when it is properly glued down to a stable substrate, the expansion and contraction can be overcome, allowing large surfaces to be veneered with no perceptible movement. The better the glue's ability to hold the veneer in place, the better the long-term quality of the veneer panel. I've separated these glues into three categories: flexible, semi-rigid, and rigid. In the flexible category, I've put contact cements, solvent, and water-based. In the semi-rigid category, I've put PVAs and aliphatic resin glues, commonly known as white and yellow glue. And in the rigid category are epoxies and urea formaldehyde resins. Now I've created what I think is an interesting dramatization of these three categories. I've poured out a strip of glue and allowed them to dry for a couple weeks. This is what a strip of contact cement looks like. Definitely very flexible. Here's a piece of yellow glue, much stiffer, but still somewhat flexible. And here's a strip of urea formaldehyde resin from the rigid category, quite rigid. When looked at from this perspective, I think it's obvious that the rigid glue would offer the highest possible bond, and contact cement would offer the lowest. I actually consider contact cement an unacceptable veneering glue. I know that people use contact cement, but I would not trust it for any of my veneering projects. It's an excellent glue for materials such as plastic laminate, fabric, and other dimensionally stable coverings, but not for veneer. It may hold down, but not well enough for quality veneer work. The glues I use are in these two groups, the semi-rigid and the rigid. The main difference between the rigid and the semi-rigid is the rigid cures by catalytic action. You mix part A with part B, and you have a certain amount of time to work before they harden. Semi-rigid glues cure by evaporation. When all the moisture has evaporated, the cure is complete. In my opinion, rigid glues will always give you the best glue line possible. Urea formaldehyde resins have been industry standards for veneering for many years. I may use rigid glues when I want the best possible glue line, but I always prefer yellow or white glue when the extra performance isn't needed. They're easier to use, there's no mixing, and they set faster. Leftover glue can be reused another time. Here's how I choose. I have a list of conditions. If I go through the list and get a yes to any condition, I use a rigid glue. If I get a no to all the conditions, then I use a semi-rigid glue. Here's my list. Horizontal surfaces, like tabletops. These surfaces tend to get scrutinized more, often get a high polish which will show up any movement in the veneer, and usually see more abuse, like wet glasses. Delicate veneers, such as burls and crotches. These veneers are prone to cracking and splitting. Also, as the glue dries, veneers can show faint fissuring when using a white or yellow glue on this type of veneer. Rigid glues are best for these veneers. Multiple veneers together, such as marquetry or a panel with different veneers going in different directions. These are conditions where there is more stress than usual. Oily veneers, such as rosewoods. White and yellow glues do not often adhere well to these veneers, so I use a rigid glue.
Great.
Large panels or any item that may take some time before pressure is applied. Although this issue is not about rigidity, white and yellow glues tack up fairly fast. On a large panel like this 3x8 figured anagray tabletop, you may not get this under pressure before the glue begins to tack. With white and yellow glues, I like to be in the press within 2 to 3 minutes. Most rigid glues give you about a half an hour open time on the average. If I go through this list and get a no to every condition, I'll use white or yellow glue. Now I keep on saying white or yellow glue, so the next question is which one to use? And the answer to that is really either one. The differences are not that great. It's worth knowing that yellow glue is really a white glue with yellow added. They're both PVAs, polyvinyl acetates. More accurately though, a yellow glue is a white glue with a few added properties. They usually set faster and are a little harder and more heat resistant. Setting faster is a disadvantage for veneering, but the other two properties are benefits. I usually use a yellow glue and work faster, or add a little water to slow them down. Manufacturers say you can add up to 5% without weakening the glue line. Be careful though, don't overdo it. Now if I check the list on this burl tabletop project, horizontal surfaces and delicate veneers are conditions we have. So I'm going to use a rigid glue. And of these, I'm going to use the liquid urea resin. Urea formaldehyde resin comes in two types: a powder that you mix with water and a liquid resin that you mix with a powdered catalyst. I prefer the liquid type. It mixes easier and usually sets a bit faster, although setting speed has more to do with the manufacturer's specs than the type of urea. Be aware that these glues require a certain temperature to set, which is usually above 65 degrees. Epoxy is an excellent veneering glue in the rigid category, but I don't usually use it because it's high saturating. This means a lot of bleed through, which will be hard to sand off later. Both of these glues are somewhat toxic. Always work with proper protection and adequate ventilation. Now that we've considered the options and chosen the right glue for this project, let's take a quick look at the glue applicators. My objective when spreading glue is to put down a uniform glue line in the shortest possible time. A brush like this is just not the right tool for veneering. It's too hard to get a uniform glue line, and it's much too slow. These are the glue applicators I use. This is a nice tool. It's basically a notched trowel with a can attached to it. You fill the canister here and pull this lever to dispense. I don't generally recommend notched trowels. Most of them are too coarse, like this one, and put down way too much glue. This one I like because the notches are so fine. One of the simplest and cheapest spreaders is this paint roller and paint pan. You get a very uniform glue line, and this 9-inch width will cover a lot of surface quickly. I use this black foam cover. It's inexpensive and does an excellent job. Another version of this roller is one with a built-in hopper. You pour the glue in here and pull this trigger. This engages the internal roller with the rubber roller to dispense glue. When you've applied enough glue, you want to spread it around, lift up, and the rollers are disengaged, allowing you to spread without applying more glue. Although I like both of these, there are two considerations. They're a bit of work to clean them out, and they're not really practical for catalytic glues. If you ever forget to clean them out, immediately after pressing, the catalyzed glue would ruin it. Since this project will use the urea catalyzed type glue, I'm going to use this paint pan. I'm all set up here. The press is ready, my substrate and cauls are cut to size, and the face and backside veneers are prepared. I always check to be sure I've got everything in place before pouring glue. There's nothing worse than having the glue spread and discover you're missing something. Panic time. I'm actually going to wear a respirator while I spread the glue, but I'll narrate to you what I'm doing while I go. Is that all right? I'm dispensing the proper portions of glue. If you notice, I'm using a scale so that I can get good accuracy. Now I'm adding the catalyst. Let's stir this up. I'm careful to mix it real well so there aren't any lumps. Notice I'm using rubber gloves along with the respirator, as some of the catalysts do have some toxic chemicals in them. One tip while I'm mixing the glue together: on some woods, especially very dark ones, lighter glues can sometimes show up later where the glue fills in pores, seams, and other surface imperfections. To avoid a noticeable color difference, I occasionally tint the glue with aniline dyes used for staining woods. Most glues are either water or alcohol soluble and will mix in fairly well. Notice I start by putting the lower caul in position. Place the substrate up on top. All right. Let's pour the glue into the paint pan. Okay, we're ready to roll. Remember, you always put the glue on the substrate, never on the veneer. This only adds unnecessary moisture to the veneer, prematurely causing it to curl and swell. I'm trying to achieve a thin but uniform glue line. Too much glue means excessive bleed through, and not enough means poor adhesion. I say about what you would use when trying to paint a wall with just one coat. Let's take a close look. There's enough here to make a trail when I drag my finger through, but not enough to run if I were to hold the panel up vertically. Let's clean up that finger mark. Move the panel aside temporarily. Place the walnut burl, veneer tape, face down against the caul. Flip the substrate over and place it on top of the walnut burl. I also try to line up the veneer and the substrate carefully. Okay, now I'm going to roll the other side. Place the mahogany backer veneer on top of the substrate. Line up everything carefully. Again, make sure that the veneer tape is not face down into the glue. Place the cover sheet on. I'm using masking tape on the four corners to hold the entire sandwich together. This will prevent anything from slipping while I go to place it in the bag. Slide this sandwich in the bag. And seal the bag with the closure system. And turn on the pump. The bag is applying pressure to the veneered panel. Look closely, you can see that the vacuum is taking hold, applying pressure very evenly to the entire panel. You can hear that the vacuum pump has reached full vacuum because it has just shut off. It will recycle when needed to keep the pressure up to proper levels. One last thing I do before cleaning up the paint pan is to pour a little glue in this baggie. Seal it up and flatten it out. I'll show you what this is for later. I'm going to go clean out this paint pan. I've only got a half an hour before this glue starts to kick. I'll be back in a minute. While this is under pressure, I'd like to take a few minutes to talk about presses, since this has always been the main obstacle to working with veneer for the small shop. The glues I recommend all require pressure to achieve a good bond. Only contact cement can get away without a press. I think this is the main reason people reach for this quick fix. If you don't have a press, there really isn't any other choice, although I don't consider this an option. Getting set up with a press is not that big of an obstacle as it used to be with the recent introduction of vacuum presses. It's easy to get started with a reasonable investment. You can make your own traditional press with these press screws, and even a few clamps you can get by on small projects. The most important factor in successful pressing is not so much pressure, but uniform pressure, although reasonable pressure is necessary. Having it evenly over the entire surface is the key. This is why vacuum presses work so well. They may not apply tremendous pressure, but the weight of the atmosphere is always perfectly uniform. I've used vacuum presses for years with excellent results, not to mention their ability to perform curved and shaped work. When you're done, you can roll them up and put them away. Great for the space-conscious shop. If you have a small piece to press, such as a drawer front, you can probably get away with just clamps and a couple of thick cawls like this 1¼ inch particle board. The important thing is to make sure you have enough clamps to get uniform pressure. The glue can migrate and puddle up in areas of lower pressure in between the clamps. To make a more substantial press, you'll need press screws and some 2x hardwood stock and 1-inch thick platens top and bottom. I'm not going to take the time to show you how to build one, but this is generally how one would look. There is an article in an older issue of Fine Woodworking, issue July-August 1984, number 47, which gives you a good layout of how to make your own press. Also, the people that manufacture these press screws, the Adjustable Clamp Company, have a simple brochure that shows you how to build a good screw press. There are two other methods of laying down veneer that do not require press at all. One technique is called hammer veneering, which is not very popular anymore, but used to be the common method for pressing veneer. You would use this flake glue made from animal hides, heat it up in this glue pot, and brush it on the substrate. Then, before the glue cools and hardens, you use this special hammer to apply pressure while drawing the excess glue out to the edges. This technique is used mainly by antique restorers that need to use the same glue that was used originally on the piece. Also, it can always be reactivated for later repairs. I don't recommend this technique for veneering, but if you're up for a challenge, this would definitely be one. The other technique I do recommend on very narrow work only, believe it or not, is this household iron. With this method, you use white or yellow glue, brush it on both surfaces, and let it dry. Then, with a hot iron, press the veneer in place by rubbing firmly back and forth. The heat reactivates the glue, giving you a surprisingly good bond. One strong warning though, I only use this technique on very narrow work like edges and table legs, nothing more than 3 inches wide. The high heat that is concentrated very locally would create havoc on a panel of any size. This method is not a substitute for a press. Whatever type of press you use, proper veneer preparation and glue application is the key to successful pressing. When I talk to people having problems, often they blame the press, but usually after discussing their situations, it's other things. Every step is equally important. Let's take a look at the panel and see if it's ready. With white and yellow glues, you can take the work out after pressure and capillary action has pulled the glue in as far as it will go, giving you the initial bond, which I find is about 1 hour, although more time is always beneficial. With two-part glues, they need to be left in until sufficient catalyzation has taken place. When the glue in this baggie turns to firm rubber, I know that it has set enough to take the panel out. I use the baggie rather than a cup because catalyzed glue generates heat and volume, which could accelerate the curing in the cup, giving you false indication. This looks good. Let's take it out. Excellent, nice and flat. If you look closely, you'll see there's a little bit of bleed through. This will sand off later. In fact, I like to see a little bleed through on open grain woods. It indicates that I've used enough glue. On closed grain woods, like this maple, you shouldn't see any bleed through. The last step is to remove the veneer tape. Usually I let the glue cure overnight before I work the panel, but for demonstration purposes, I'll do it now. Now you can simply scrape and sand the tape off, but I find this little envelope licker does a great job. Wet the tape like this. Let it set for a few minutes. Wet it again. Don't soak it, just a light wetting. Try to keep the water just on the veneer tape. Let it sit a minute more and peel it off. Any tape that didn't come off can easily be removed with this scraper. There. I've never had this method lift the veneer, even with regular white and yellow glues. I'm going to stand this panel up like this overnight so the air can circulate and remove the excess moisture from both sides. If I laid this panel down like this, by tomorrow morning it would be quite warped, since the moisture gets trapped on the underside. So that I can finish this demonstration today, I pressed and trimmed with solid walnut another panel a few days ago that is ready for sanding and scraping. I put in this little inlay here that adds a nice touch. It's one of these details that looks like a lot of work, but it's really quite simple. Let me show you how I did it. First, I took these 3 pieces of veneer, 2 pieces of maple, and 1 piece of ebonized veneer, and put them in between. It's hard to get jet black veneer, and this dyed pair is a great substitute. In fact, you can get dyed veneers in many different colors. I then glued the 3 pieces together and clamped them between these 2 boards. Once it was dry, I sawed them up into strips and glued them to the solid walnut edging, like this. After that, I mitered and clamped these pieces onto the table edge like normally would, and I have this sharp detail that looks like I painstakingly inlaid each veneer individually. I also shaped this walnut first, since I really want to work with the top as little as possible after sanding. Now comes the part that makes every woodworker a little nervous. The fear of sand through. That moment when you look down and see the substrate peering up at you. Whew. But by paying careful attention and using the right tools, this danger can really be eliminated. This tool is asking for trouble. Makes me shudder. These are the ones I use. A cabinet scraper and an orbital sander. Now, veneer is fairly smooth and doesn't usually require the level of sanding solid wood does, but there are a couple of things you're trying to achieve. First is to remove any glue bleed through off the veneer surface. If this is not fully removed, these will show up as light blotches when you go to apply the finish. The second job is to remove what I call the mountains and valleys. When veneer is sliced, it is bent away from the knife, similarly as a curl comes off a block plane, except with veneer, the knife cuts across the grain rather than with the grain. This bending action or peeling action causes one side to be compressed, called the compressed side, and the other side stretched, called the pulled side. The compressed side has a tighter grain with what I call valleys, and the pulled side has the looser grain with what I call mountains. This is one of the reasons that when you book match veneers, the adjoining piece can sometimes look a little lighter or darker. Compression, pulled, compression, pulled, compression, pulled. Mountains and valleys. If you hold the veneer up like this and look at it across the light, you can see one side is raised grain and the other side is somewhat pitted. The level of this will vary from veneer to veneer, and it is more prominent near the edges of an individual piece of veneer. When I sand, my goal is to remove the mountains and go to the bottom of the valleys. On occasion, I will leave a deep valley and let the finish fill it, better than sanding through. I start a general cleanup with a good sharp cabinet scraper. Give it a thorough once over, concentrating on any glue spots. Sometimes I wipe the veneer with a little bit of alcohol just to see if I've gotten everything. Now there's a little spot there. I could see I need to give it a little more scraping. Looks good. I go to this orbital sander, usually 120 grit to start, finishing up with about 220. In general, I find this is high enough. Since I don't apply an oil finish, I feel veneer needs more protection than oil finishes offer, and is much more absorbent than solid wood. I use lacquer or polyurethane, but any coating type finish will do. Remember, long, even strokes don't stay in any one spot. Doing this kind of action will get you a burn through. Go back and use a scraper if you see a spot that needs a little extra work. I get much better control with this tool, and I can see what I'm doing after each stroke. I think this is about done. Let's dust it off. And carefully take a look. Okay. I get down like this to look for any pits before I go to a higher grit. Looks good. Now I'll go up to 150 and then to 220 to remove the orbital marks created by the 120 grit. Well, I think this about does it for this tabletop. The only thing left to do is put on a finish and make the rest of the table, of course. I hope this video has given you the information and the confidence to try your hand at veneering. It opens up a lot of new possibilities, and I think it's great fun also. If you're already veneering, I hope I've given you additional tips to advance your skills and try new things. Being able to stand back and enjoy the piece you've just made with your own hands is one of the great things about woodworking. Sometimes veneering can seem highly technical and a bit daunting. My main advice to anyone first starting out is samples and testing. Don't plan a big project and then go at it. Get some veneer, cut a bunch of 12 by 12 samples, and practice. Try to overglue. Try to underglue. See what happens. Make some test seams. Sand a panel till you burn through. This will give you some great information. Often when I'm working with a veneer I've never used before, I'll press up a sample to see how it performs before starting the project. The more information you have, the more confidence you'll gain. I've given you the basics, now it's your turn. And by the way, don't forget to have fun.